Thank you. Thank you. Okay. So, Gina, follower, a regulator. So here we will connect a Gina diode, okay, at base, between the base and emitter of a transistor. So suppose we have a transistor, okay, and then we have same voltage divider circuit, VCC. Here we have resistance connected to base, and here what I am putting instead of resistor, I am putting a Gina diode here, and here again you have emitter resistor. Then make it ground. Say this resistance is R. Okay. Here you have voltage drop VBE. Okay. And if I take voltage here at ammeter, okay, I call this voltage the V naught. Okay. And this resistance become for me a root resistance RL or RE, whatever you want to write. Okay. And now from here you can see that if this voltage is sufficient to make this diode turn on, okay, you know the reverse diode works in reverse bias. So once it has a turning voltage, okay, that background voltage, it reached on background voltage or VG such that the drop is across is greater than VZ, okay, then in that case we can replace it by a battery. Okay, the same Gina voltage for this Gina diode is VZ. Okay, so if this diode is conducting, then we have this simple circuit. I can write here that I can replace this by a battery, okay, of VZ, and I can write this loop. I can write minus VZ, and this is VBE, and this is my V naught equals to 0. So my V naught becomes now VZ minus VBE. Okay. Now this is constant. So I want a regulated voltage, a constant voltage in output. So you can see here this voltage is constant because for given Gina diode, VZ is constant and VB is always constant. Okay. So this is the voltage regulation. And if you say VZ is greater than VBE, okay. Suppose this is 0.7 and you are taking a Gina diode which has 6 volt or 10 volts. In that case, this VB is negligible compared to VZ. So you can simply say the V naught will be your equals to V Gina. Okay. So whatever the Gina terminal voltage, the output will be that voltage in this loop. Because in this loop, this VB is negligible. Okay. So this is your voltage follower regulator. Okay. Voltage follower regulator circuit. So is that clear? This circuit is clear to you? Okay. So if it is clear, okay, let us do some 1 or 2 problems based on this circuit.
सर मिटाइएगा मत 2 मिनट.
हाँ. So हमेशा हमको ये लूप लेना है, बेस एमिटर लूप लेना है. ओके. सो फर्स्ट यू टू मेक श्योर कि ये डायोड टर्न ऑन है कि नहीं है. So by turning on diode means the voltage across diode should be equal to or greater than VZ. Then only it will conduct. Okay, then it will become constant. Otherwise, if the voltage is such that it cannot make this diode to conduct, okay, then that will be your open circuit. In that case, this will not work. So your voltage will be here such that it is high voltage compared to this one. Okay, suppose here you want 10 volts, here 20 volts. Okay, because voltage drop here VB is very small, IB is very small. So So you can check, or you have to check first whether your diode is conducting or not conducting. Okay. So let me solve one problem. So I have a transistor. Okay. I am taking a R. This is 15 ohm. Okay. I am taking voltage across this load. This is my ammeter. This is my collector. So this is again VB. This is VB. Okay. This is your this circuit. Okay. And here I am writing a giving you resistance of 680 ohm. 680 ohm. And V input value I am giving it 20 volts. 20 volts is my V input I am giving here. Okay. 680 ohm resistance here, 15 ohm resistance here, and I need to find out the value of IL. What is IL? I load. Okay. IB, IZ, how much current is flowing across the GNR. Okay. So this all values I need to calculate. So, and GNR voltage is given, this particular case is given 10 volts. You say 10 volts is required to make this diode conducting. VB value is given 0.7 and beta value is given, this case, your 80. Now, first of all, you need to check whether this diode is conducting or not conducting. Whether 10 volts voltage coming here. Okay. So this is the voltage value in this particular case. Okay. I may choose the voltage such that it is conducting, but sometime, okay. So just for making sure it is conducting, you can check. Okay. So if you can assume diode is non-conducting. Okay. In that case, it will be open. Okay. And in that case, this will come your the current will come from here. Your 20 volts, your resistance I, this current will become your IB. Okay, this is VB, and then this current will be IL, which is nothing, is ammeter current. You can write this beta plus 1 IB. Okay, and you can solve the IB. Once you know the IB, okay, once you know the IB, you can multiply this resistance with IB, and you can say how much voltage getting drop here. So you have 20 volts here. After getting drop here, how much voltage coming here? If this voltage is greater than 10 volts, then this will be conducting. Otherwise, it will be non-conducting. Okay. Let's first check how much is voltage at this point. What is the voltage at this point? If I assume this is not conducting. Okay. So you can check this one. Okay. So minus 20. Okay. You can write 680 into IB plus, I'm going through this circuit. Okay. Plus BB, and then I have 15 resistance, 15 into IL. Okay. IL is nothing, that is my beta plus 1 IB equals to 0. Okay. Beta value is given 80 in this particular question. So you can always find what is my IB. So my IB will be 20 minus 0.7. Okay. This is 0.7. This was 19.3. Okay. IB will be 680 plus 15 into 81. Okay. So please calculate this IB value. Tell me what is the answer is coming. What is the value of IB? Find the value of IB. okay, and then multiply this by 680 and tell me how much voltage drop is there across this diode. So how much is IB?
10.1 microampere.
10 point, huh?
Yes, sir.
10.1. Somebody other also check. Okay. Microampere. Okay.
Sir, milliampere.
10.1 milliampere. Okay. So 10 into 680. That is, this is almost 0.5 kilo ohm. So obviously the voltage drop here will be around 5 volts. Okay. So here voltage 20 minus 5. Here will be voltage will be greater than 10 volts. Just check it. How much voltage drop is coming? Around 680. Okay. So voltage drop around this here. Okay. So we at 680 ohm. 680 ohm resistance. So 680 into your current is you saying 10 milliampere. Okay. So how much voltage drop is coming? Tell me. 680 into 10 milliampere. So this is almost 6.8 volts, isn't it? How much coming? 6.8?
6.93.
6.93 volts. Okay. So here you are 20. Okay. You're losing 6.93 volt here. So you are getting how much here? You're getting almost 13 volts. This is almost 13 volts.
Yes, sir.
And you require only here 10 volts. Okay. That means that this assumption is wrong. Okay. This diode is conducting. So once this diode is conducting, you can replace this diode by a battery, okay, of 10 volt. Okay. So this is just for checking. Okay. Nothing to do actual calculations. Just to make sure this is conducting. Now we know this conducting. Okay. Now I can erase these values, and now my circuit will be different, and I can calculate my values. Okay. So now obviously you have this one. Okay. So you have 20. Now this you have this loop. Now you know this is 10 volt. Okay. So now you can go this loop. You can find how much current is coming. I. You can find I current. So here total current is I coming when this is not open, or this current become I. Okay. And some current will go here IB, and remaining current will go here IZ. Okay. So now you can calculate what is the value of this this one. Okay. And you can also find V naught also. Okay. So first let us find out V naught. What is the V naught? So in this circuit, minus VZ plus VB plus V naught equals to 0. Okay. So V naught will be obviously 10 minus 0.7. It's very simple. Like we have done whenever this is conducting, then this will become very simple. Okay. So you have 9.3 volts. Okay. Now once you know the V naught here, you can find current IL. Okay. IL is nothing. That is your this case particularly this is your ammeter current. Okay. This is your ammeter current. IL. So IL will be your 9.3 volts divided by 15. Okay, 15 ohm. You know volts. You know this one resistance. You can find the current. What is the current value? Tell me. IL.
0.62.
Okay. So this is your 0.62 ampere. Okay. Now this is almost equal to IC. Okay. Now once you know the IE, you can calculate IB. Okay. So what is the value of IB in this particular question? So IB will be nothing. IB will be your this IE upon beta plus 1 or IC upon beta, whatever you want to write. Okay. So from here you can find the value of IB. Okay. So IE is 0.62. Okay. This is your 81. So how much is coming?
7.6 milliampere.
7.6 milliampere. Okay. 7.6 milliampere. You can little bit exactly. Okay. 7.6 milliampere. You know IB. Now you want to find. You got IB. You got IL. You want to know IZ. Okay. So if you know total I, you can find IB, you can calculate IZ. Okay, so your IZ is simply I minus IB. Now what is I? I can you calculate from this circuit. So I will be what? Minus 20 plus 680 into I, okay, plus VZ is 10 equals to 0. So your I will be simply 20 minus 10 upon 680, that is 10 upon 680. How much is coming? 14.7 something, okay, 14.7 milliampere. Okay, so you can find your 14.7 minus IB 7.6. This is a milliampere or microampere?
Milliampere.
IB
A milliampere.
milliampere. Okay. So you can find what a difference, okay, and you can calculate what is coming. I, okay.
7.1.
7.1. 7.1. This is 7.1 milliampere. Okay. This is your Zener follower regulator. Okay. So if you doubt is the push लो. Any question होता है लेके इसका. Then we will do previous year problems. So अभी हमने भी solved at least 20 problems of transistors, okay, and you see transistors is very simple, okay, and your exam also say similar type questions they ask. So only you should have confidence to solve. You should be able to apply this KVL, KCL, what you will learn, okay, and it's just very simple, okay. There will be always two loops in the circuit. Just you need to apply KVL, and whatever the requirement is in the question, you need to find that one. This is your this is your 220 ohm. Okay. Again, I'm giving you a 20 volt input. Here we have Zener diode of 12 volt. Okay, and I'm putting here a one resistance of 1 kilo ohm. Okay. So you need to find out V naught. What is the value of regulated voltage? Okay, find V naught. Okay, then of course you find IG, IZ, IB, and IL, and IR. So let us say this is IR. Okay, so IR is coming here, IB is going here, IZ is going here. Okay, so assume this diode is conducting. Okay, if you are in doubt, okay, you can again go same procedure and you can check. So this question I am informing you, okay, I am giving you that it is conducting. So you can directly solve the problem. You can find the V naught and current values and tell me the answer. So V naught is very simple, okay. As soon as you see the circuit, you know what is V naught? What is V naught?
VZ.
Okay. As soon as you find this circuit, okay, you know this voltage plus this voltage equal to this voltage.
11.3.
Okay.
volt.
So that will come 11 points. So that will come VZ minus VB. Okay. This 12 minus 0.7, 11.3 volts. Because when it is connecting, you can replace this by a battery.
So what is the beta value?
Beta value for this question 500. Beta value is 500. So first calculate I, or you can also find first IL also. Okay, IL. So what is IL? 11.3 volts divided by 1 kilo. This become 11.3 milliampere. IL. Now once you know the IL, you can find IB also. So IB will be either 11.3 upon 500 or 501 also. Okay, beta plus 1. So 501. This will give you how much? I will come some microamperes. How many microamperes coming?
22.
22.
0.55.
0.6.
0.56 जो भी है, okay. 0.56 microampere. IB पता चल गया, तो बस अब आपका I निकाल लो, IR निकाल लो सर्किट से, इस सर्किट से IR निकाल लो, तो IR कितना आ जाएगा आपका? 20 minus 12 upon 220. Okay. IB आपके पास है ही. So I कितना आ रहा है? I आपके पास आएगा
36.3 milliampere.
Okay. So this will come 36.3 or 4 milliampere. I have okay, just check. And once you know I, you can easily find out your IZ. IZ will be your I minus IB. Okay. So this is just if you convert in milliampere, it is almost negligible, 0.022. Okay. So this will almost come in this equal to this one. Okay. So it's coming 36.2 milliampere. If you subtract this one, check it once. Is it okay? So,
Yes, sir.
so if your people are okay, and we can now go to for previous year problems. Okay. So I'm solving the previous year problems. Okay. So have you have been given a battery VBB. Okay. of 9.7 volt. This is connected here, and this is connected here. RC, and this is given as 12 volts. Okay. So this is RC value is given 2 kilo ohm. Okay. So VB is given in the question 0.7 volt. Okay. VBB you can see 9.7 volt. RB is 300 kilo ohm. This is RB. Okay. 300 kilo ohm. RC value is given 2 kilo ohm. Okay. So they have given this circuit. Now they have given 4 options. Okay. They are asking for this given circuit. Okay. Which of the following option is correct? VB is 0.7. Okay. Now they have given you option A. They are plotting IC versus PC. That means they are plotting common ammeter output characteristics. Okay. So option A, they are giving this is 32, and this is giving here 9.7. Okay. And here they are saying this is my Q point. This is 30 microampere, 32 microampere, and 35 microampere. Okay. So in output characteristics, what is the thing we keep constant? So this values of which current?
IB.
IB.
IB, very good. So these are IB values. Okay. This is IC and this is VC. So this IB values are given. Okay. So you just need to calculate the IB and you need to find out which of the following graph is correct. Okay. And the second option, they have given you again same graph. Okay. Okay. End points are changed. This time end points are 12 and 6. Okay. And values again 30, 32, 30, 32, 35, 30, 32, 35 microampere. Okay. And this time they are giving the operating point as again at 30 microampere. And 32, sorry, 32. This time they are giving on this is at यहाँ पे 30 था, यहाँ पे 32 दे रहे हैं. Q. Okay. Option C is आप निकालो. Which of the following is correct? Which of the following correct graph is correct? Okay. And third option, they are giving IC. End points are given 12 and 6, 12 and 6, and Q point is given 32 microampere, 30 microampere. Okay, Q is given 30 microampere, 30, 32, and 35. Okay, and the D option is again you are given 3 option. So D option is the end points are 9.7 and 9.7, and say this is your something you can write 12. Okay, and Q point is this 35, 32, 30. Tell me which of the option is correct.
सर बीटा का कोई वैल्यू दे?
बीटा का कोई वैल्यू नहीं दे रखा.
अल्फा का
कुछ नहीं दे रखा, वैसे निकालना है. जोत का बढ़ेगा, जब बढ़ेगी क्या?
सर ऑप्शन सी.
बीटा का वैल्यू तुम लिखो 50 लिखो. ओके, बीटा वैल्यू you want, that is actually beta value is not required this question. Beta value is not required this question. Huh? Okay. You just need to find first IB. IB is coming how much?
30 microampere.
IB is coming 30 microampere. Okay. So this option here 30 is there, here 30 is there. Okay. Nowhere 30 is there. So this 30 is correct. Then you have to see the end point. End points are what? This is your IC saturation. And this is what? This is VCC. The VCC is 12 volt. So this cannot be answered. Okay. VCC should be 12. So if you remember the graph, these end points are this are VCC, and this value is nothing, is IC saturation. Okay. So let me now solve. Okay. What is the
Sir, option C होगा.
option C होगा? Okay. So you have values what? IB. This is your IB. So you can find VBB. Okay. Minus 9.7 in this loop plus 300 kilo ohm. IB. Okay. And this is VB 0.7. 0.7 equals to 0 here. VB. Okay. If you want, you can make this ground position. Then you have IB. IB is 9.7, 0.7 upon 300. Okay, this become 9 upon 300. Okay, this become 1 and become 3, and this is 5. 30 to 10 raised to power minus 5. That is 30 microampere. Okay, so IB is 30 microampere. So Q point should be on this 30 microampere. Then you need IC saturation. IC saturation is nothing. Make VC is 0. Okay. So then VCC is 12 upon RC 2 kilo ohm. This become your 6 milliampere. Okay. This should be 6 milliampere. So you have now, and VCC is 12. So VCC is 12. So the graph which contains these all things, 30 microampere, Q point should be here. Okay, this should be a 12 and this should be a 6. This is the correct option. Clear? Okay, so let us now solve other problems. Okay. Now you have been given a voltage divider circuit. Okay, this is given 6 volt battery. This is your 0.5 kilo ohm. This is given R1, this is given R2. Okay, and here one resistance is 2.5 kilo ohm and 6 volt. Okay, VB is given, beta is given 50 and VB is given 0.7. The question is asking what is the value of R1 upon R2. Find the value of R1 by R2. Calculate. क्वेश्चन में IC इक्वल टू 1 मिली एम्पियर दे रखा है। IC is given 1 milli ampere and you can take IC equals to IE always. So these two ratios are unknown, so you need to find the ratio. Okay, so करना क्या है, just you need to find this voltage VB. Now this battery is given, but these resistance are unknown. So obviously with this voltage divisor, you cannot find this VB, but in this loop you can find VB. So if this is VB, if this voltage is VB, okay, and this voltage is VBE, okay, and if you know this voltage, you can find VB. And this voltage, how can you know? You have been given this current IC 1 milliampere. So you know this voltage drop. You know this voltage drop. You know this voltage drop. You can find what is VB. Okay. So obviously your VB will be what? VB will be your VBE plus this is IE. Okay, call this RE. Okay, I am taking this is 0.7. I am taking this IC equal to IC. I am taking this as 1 milliampere. Now RE is 0.5 kilo ohm. This cancel out. Okay, so you got 0.7 plus 0.5, that is you got 1.2 volts. Okay. Now you know the VB. And what is the formula for VB? The formula for VB is from voltage division 6 upon R1 plus R2 into R2. Okay, that is 6 upon 1 plus R1 upon R2. That is your VB, and that is we have already calculated 1.2. So here from this equation, you can find the ratio R1 by R2. Calculate.
-1 to 2.
1:2 or 1:4? Check it once more. 4. R1 by R2 should come 4.
Yes, at 4.
So you have this VB, okay? So you can get here 1 plus R1 plus R2 into 1.2, okay? So you multiply this one 6 into 1.2 plus R1 upon R2 into 1.2. So R1 upon R2 into 1.2, that will become 6 minus 1.2. So R1 upon R2 will be 6 minus 1.2 upon 1.2. Okay. So this become 4.8. This become 1.2. Okay. So this become 4. So R1 by R2 is 4, or R2 upon R1 is 0.25 ratio. So it's better you solve yourself. Okay. When you solve yourself problems, okay, then only you understand that you can feel confident. So this is 5 kilo ohm. Okay. Then this is 10 volts. 10 volts. Okay. Again, voltage divider circuit. This they given 5 kilo ohm. This also 5 kilo ohm. Okay. Here they have put 10 kilo RE. Okay. So then question they are asking what is the value of VCE? Okay, and they say we take VB 0, neglect VB, and beta they are given 100, and they are asking what is VCE value. Find out VCE. So this time is VB is 0. So whatever voltage coming here, that voltage will be equal to here. Once you know this node is voltage, you can find IE. Okay. Once you know the IE, automatically you know what is IC, and then you can use the circuit and you can calculate what is VC. Okay. So say this is VB. So if I take approximation method, then IB is 0. Okay, and your VB will be nothing. VB will be simply 10 upon 5 kilo ohm plus 5 kilo ohm into 5 kilo ohm. Okay, it has become 10, and you just become your simply 2. So this become your 5 volts. So now you know VB. So now this VB is equal to what? VB plus your VB plus this
IRE.
what IR.
2.5 volt.
So VB कितना रहेगा? VB आपको given है 5 volts. So IRE आपको क्या लगेगा? This will be 5 volts because to RE is 5 volts. So from here you can find I 5 upon RE is 10 kilo. Okay, 10 kilo ohm. This is 1 to 0.5 milliampere. Okay. Now you know IE, you can say IC is also 0.5 milliampere. Okay. Now you can write this loop. This loop में क्या आएगा आपका? In this loop, you can write you want VCE. So VCE is nothing. VCC minus IC RC plus RE, isn't it? In this equation, VCC, ICRC, VCE, IERE, and taking IE, IC equal. So this will be VCC. VCC is 10 volt. IC you saying 0.5 milliampere, and RC is become 15 kilo ohm. Okay. So now 15 kilo ohm means now you can say the VCE is 10 minus this cancel, this become 7.5. This come how much? 2.5 volts. Check it coming or not.
Yes, sir.
Yes, sir.
Same type of questions here. So, thank you. This is June 2018. June 2018. Okay. This is 5 kilo. This one 20.7 volt. Okay, and here they are given resistance here. You need to make sure इसमें यहाँ से connected है कि यहाँ से connected है. Okay, so वो आपको ध्यान होना चाहिए जब भी आप लिख रहे हो केवल लिख रहे हो. Okay, and this is they are giving 500 kilo. Okay, and here they put one capacitor C1, and here again you have same You have RE value, they're giving you 1 kilo. VBE, they given you 0.7 volt. Okay. Now they asking you find the value of IB. Okay. Beta, how much you can take beta value? So beta value you can take 500. Let me check with this one. How much beta is given question? Take 100 beta as a 100. Beta value 100. So beta value is 100. Okay. They're saying find IB, and they are given the options A, B, C, D. Okay. 40, 30, 40 microampere. Okay. 30 microampere, 44 microampere, and 33 microampere. Okay. Which of the following is correct? Now, you should not vary when there is a capacitor. Why? Because so far we are not doing amplifier. We are not doing AC analysis. We are so far only restricting up to DC. We are DC voltage. We are applying DC analysis. So for DC, this capacitor is always open. So wherever circuit you have a capacitor, you can simply remove the capacitor, because for DC your capacitor is open circuit. So this means nothing. So no current will flow here. So you have simple DC circuit. Okay. You can write for DC. Okay. Capacitors act like open circuit. So no need to worry about capacitors. Tell me what is the IB value? So analysis is simple.
Sir, 0.03 milliampere.
Microampere count करो, microampere में.
Oh, sorry, the 30.
30 तो check करो एक बार से.
33. Sorry, sir. 33.
This is the correct options. Okay. So you can simply use here minus 20.7. Okay. Now this current is going IB. So obviously this current is your IB, and this current is your IC. Okay. So you can write plus IB into 500 kilo ohm. Okay. And then you have VB, that is 0.7. And then you have this one IE, that is beta plus 1, beta is 100. So 101 plus RE 1 kilo ohm plus IB equals to 0. So IB will be simply 20.7 minus 0.7. Okay. And this has become 601 kilo ohm. This is 101 and this is 500. So 601 kilo ohm. And if you solve this one, this should come 33 microampere. Anyone else? किसी का आ रहा है?
Yes, sir.
तो ये क्या 20 अपॉन 600 हो गया, 33 आएगा. Okay, 33 microampere. December 19. Again, this is given 20.7, and this is 5 kilo ohm. This time I'm taking from here, not from here. I'm taking from here. Okay, and here say resistance is 500 kilo ohm. Okay, and this is my, and this is simply grounded. IE. Okay, here one capacitor is there. Okay, and here also one capacitor is there. So they say find IB. Find IB. This time you can take VB 0.7 and beta you can take 100 and find IB. So DC analysis you can make it open. So transistor is out of picture. Now you know this current should be IB, and this current, whatever current always goes in collector terminal, it is collector current IC. So you can take this current. Okay, this current is I equal to IB plus IC. So in 5 kilo ohm, you have current is flowing IB plus IC. Okay, and solve this. I am giving you options. Okay, options are 20 microampere, B is 40 microampere, C is 10 microampere, and D is again your 100 microampere. So just
So
think,
20 microampere.
20 microampere the answer. Okay. You can check it. For this is because this will go open. No need to worry about this one. Okay. Again, you are getting minus 20.7 plus IB plus IC. Okay. So IB plus IC, that is you get IB and IC is your beta IB. Okay. So you can write this curve as a beta plus 1. Beta plus 1 and beta is 100. So 100, 101. 101 IB and resistance 5 kilo ohm. Resistance is 5 means, are you writing what I'm doing or should I write everything? Okay. Let me write
20 microampere.
20 microampere. So minus 20.7, then you have IB plus IC. IB plus IC into 5 kilo ohm. Okay. And then you have IB into 500 kilo ohm. Okay. And then you have VB 0.7 here. Okay, this 0. So you got what IB, this minus 20.7. This become beta plus 1 IB, 100 on 100 to 1 into 5 to 10 to the power 3 IB plus 500 to 10 to the power 3 IB plus 0.7 volt 0. So your IB will be now 20.7 minus 0.7. Okay, and this you have 505 plus how much? 500. 505 kilo ohm. 505 kilo ohm plus 500 kilo ohm. Okay. This become 20 upon कितना हो गया ये? 1005 kilo ohm. Okay, and we solve this one. This is almost 20 microampere. Okay,
19.9.
19.9 microampere. Okay, so this is your answer. Okay, so I'm stopping here. Now, see, transistor is we have finished transistor. Okay. Now only the part is transistor remaining, that is your amplifier. We call it like a AC amplifier also, AC analysis of transistor. So AC analysis of transistor I will do at the last. Okay. So after we have almost finished here, I will do 1 or 2 problem more here of transistor. Then we will go to the then we'll start operational amplifier, and it will take some 8 to 9 classes for operational amplifier. And once operational amplifier is finished, okay, then at the end we will do a AC analysis. Okay, and most of the problem, diode, transistor, and other problems which require ACs, we will do that some problems of AC analysis. Okay, that will be miscellaneous problems. So I'm stopping here.
सर सर गेट के लिए कौन सी पार्ट मोस्ट इम्पोर्टेंट है?
भी गेट के भी ट्रांजिस्टर में तो ऑलमोस्ट सेम सिलेबस ही है, सारे क्वेश्चन आते हैं। लास्ट ईयर जैसे आपने नेट में देखा, आपका ट्रांजिस्टर से क्वेश्चन आ गया था, डायोड से क्वेश्चन आ गया था। ठीक है, अब तीन टॉपिक है, डायोड, ट्रांजिस्टर, ओप एम्प, किसी से आ जाएगा, कुछ भी आ जाएगा। ओके,
नहीं सर, ट्रांजिस्टर का वो जो एसी एनालिसिस वो छोड़कर जाए, और
वो रेयरली आता है।
ओके ओके,
मतलब गेट में आया वो only 1 or 2 times they ask questions. Okay, so that require 3 classes for AC analysis. If you want to skip, you can skip, but why should we skip? Okay, that this transistor do not require more memory, na? All are same style of solving. Okay, so once you understand one thing, you can, even the exam, any new circuit is coming, you can just simply apply. You can see the circuit, you can simply analyze, you can solve. So why we should leave anything? Okay.
ओके सर,
Okay.
थैंक यू सर।
Okay.
Thank you, sir.